Hey guys, I'm going to go through the 1.14 through 1.16 homework. And we're going to be talking about horizontal asymptotes and vertical asymptotes. But for this first set of questions, so use the graphs of these. So we're going to use a graphing calculator, Desmos or whatever you have. And we're going to find the limits at infinity and at negative infinity and identify horizontal asymptotes. So jumping into whatever kind of calculator that you have. So the first function was e to the negative x power divided by x. And we're going to evaluate the limit at infinity, meaning we're trying to understand what's happening as the x values get larger, what's happening to the y values. And you can see that the y value there says 0. It shouldn't be 0. But let's pay attention to what happens here, if I can. Yeah. So you can see how quickly, like even before we get to x equals 5, we're super close to 0. And then really quickly we get almost pretty much basically 0. It won't be 0, but it will approach 0, honestly, as you get 10 and then beyond. So at positive infinity, it's going to be 0. At negative infinity, it appears that it's going to be negative infinity. So it looks like as you go to the left side of the graph, it looks like the function is just getting more and more negative. So that's what I would put for these evaluations. So the limit as x approaches positive infinity of f of x, I would say that that's equal to 0. And the limit as x approaches negative infinity of f of x, I would say that that's equal to negative infinity. Okay. And yeah. Okay. Let's see. Going on to number 2. Sine of 2x divided by x. So sine of 2x divided by x. And as we approach positive and negative infinity, it seems like this function is symmetrical. At positive and negative infinity, I would again say, well, that's not what I wanted to do. Say that the function is approaching 0 as well. It's an oscillating function, but it does appear that it oscillates between smaller and smaller positive and negative values, but still approaching 0. So here, as you keep the graph going, these minimum and maximums of the function are getting closer and closer to 0, and that's going to be for negative infinity as well. So the limit as x approaches, I'm going to say positive or negative infinity because I'm feeling really lazy, is going to be equal to 0. And I guess I forgot part C for this right here. So the horizontal asymptote, so for this graph right here, because we have a finite value right here, we would say that there's a horizontal asymptote at y equals 0. And then for here, there would be a y equals an asymptote also at y equals 0. For 3, looks like 3x squared minus x plus 1 over x plus 3. So 3x squared minus x plus 1 divided by x plus 3. Okay, so at positive, I'm gonna try and shrink the y-axis. So at positive infinity, it looks like it's positive infinity. At negative infinity, it looks like the graph is approaching negative infinity. So the limit as x approaches positive infinity of f of x, that's going to be positive infinity, and the limit as x approaches negative infinity of f of x is going to be equal to negative infinity. But it does not seem that there's any asymptotes, so I'm going to say no asymptotes. No asymptotes. And then for x over the absolute value of x, we've seen this quite a bit over the last little while. I should probably zoom in a lot. Okay, so the absolute value of x divided by x, we've looked at this one quite a bit over the last couple of lessons, but as x approaches infinity, f of x is, the function values are always just 1, and then for negative infinity it would be -1. So the limit as x approaches positive infinity of f of x, that would be equal to +1. The limit as x approaches negative infinity of f of x, that's going to be equal to -1, which means that there is horizontal asymptotes at y equals 1 and y equals -1. Okay. Vertical asymptotes. Find the vertical asymptotes of the graph of f of x and evaluate the limits from the left and from the right. So a lot of the times, should we do this with the graphs? I guess you can look at some graphs. Maybe for some of them we'll look at graphs. But let's look at 5. I think we won't really need a graph for this one right here. But so first we're going to find the vertical asymptotes. And the vertical asymptotes are going to occur, we've talked about it in class, whenever there are non-cancelable factors in the denominator. So this function right here, if I factor the denominator, I get x plus 2, I get x minus 2. Neither of these factors right here can cancel with the numerator. So x equal to -2 and +2 are going to be locations of vertical asymptotes. And we're going to evaluate the limits from the left and from the right of these vertical asymptotes. So basically, we'll say the limit as x approaches, we'll say -2 from the left of f of x. And since it is a asymptote, it's going to be positive or negative infinity. So how do you check? So let's think about -2 to the left, which would be, so thinking about a number line, you have like 0, you've got -1, you've got -2. From the left of -2, those are going to be values like -2.0001 or something like that. Something that is slightly less than -2. And if I were to place a number like that in these factors right here, I'm going to keep in mind that the numerator is always positive. But if I'm plugging in a number slightly less than that, will it make the denominator positive or negative? So if I place a number like -2.001 here, that's going to make this factor negative. If I place -2.001 here, that's going to make that also negative. And so negative times a negative would be a positive, and we have a positive in the numerator, so together it would be positive. So this should be positive infinity. But if I'm evaluating the limit as x approaches -2 from the right of f of x, kind of the same thing. I should have erased that number line. We got -2, -1, 0. So if I'm going to use values a little bit to the right of -2, that's going to be like -1.99999. If I place a -1.999 or something really close to that, that's going to make this factor right here positive, because 2 will be slightly larger than -1.999, and so that's going to result in being positive. But -1.999 here will still be negative. So on the denominator, we'll have positive times a negative, which will make it negative, but on the top it's positive. Together, it will make a negative. So this should be approaching negative infinity. So that's the way I usually evaluate those right here, to see if it's positive or negative infinity. Now we'll do the same thing for the limit as x approaches 2 from the left. So 2 from the left, that's going to be like 1.9999, whatever, something like that. That's going to make this positive, but that will make this negative. So negative here, positive here, so that should result in it being negative infinity. and then the limit as x approaches 2 from the right of f of x. So that would make this positive. That's going to make this also positive. So altogether should be positive infinity. If we want to double check in a graph, so we got 1 divided by x squared minus 4, I think it was, right? Minus 4. Okay, so on the left side of negative 2, we said positive infinity. On the right side, we said negative infinity. And then on the left side of 2, we said negative infinity. On the right side, we said positive infinity. So the graph seems to check out with what we were thinking about. Okay. Let's see right here. So for this graph right here, let's maybe factor the numerator just in case. We got x, and then we have x minus 2, and then we have x plus 1. So no cancelable factors. X equals negative 1 is going to be the location of a vertical asymptote. So we'll do the limit as x approaches negative 1 from the left of f of x. So I like using this right here because the factors are a lot easier to determine if you were to plug in this value, if it's going to be positive or negative, rather than plugging them in here. So if I plug in negative 1.001, that's going to make this negative, right? So it's going to make that negative. This will be negative, and this will be negative. On the numerator, we'll have a negative times a negative. That will be positive. Positive divided by a negative will make that negative. And then the limit as x approaches 1 from the right of f of x. Negative 1 from the right, sorry. So negative 1 from the right would be something like negative 0.999. That's going to remain positive here, so that would be positive. This will be negative. This will be negative. Negative times a negative is going to be positive. Positive divided by positive should be positive infinity. So on the right side should be positive. On the left side, negative. Let's go ahead and check. So we had x squared minus 2x divided by x plus 1. Let's kind of shorten this right here, easier to see. So on the left side of negative 1, we said negative infinity. Yep, and on the right side, so this is on the left side, negative 1. On the right side of negative 1, it's positive infinity. So it checks out. Cool. All right, secant of x. So good thing we have, if you guys have that trigonometry kind of trig and calc resource I gave you guys, it might be helpful to look it up right here. But let's think about secant of x. So from memory, I should know how to graph secant of x. If I know how to graph, secant is equivalent to 1 over cosine of x. So if I graph cosine of x, I know cosine of x goes like this right here. And it goes down and it goes up like that. It goes down, goes up like this right here. So, and it keeps going. But secant of x is going to have vertical asymptotes when cosine of x is equal to 0. And cosine of x is equal to 0. So this value right here is pi halves. And this value right here is 3 pi halves. And then the next value it crosses is going to be 5 pi halves, so on and so forth. So it will have vertical asymptotes at x equals positive or negative. I'm going to say k pi over 2 for if k is an odd integer. Because it goes 1 pi halves, 3 pi halves, 5 pi halves, so odd integers right there. And well, actually, I didn't really graph the secant part. So secant will look like, well, let me see. So we'll have our asymptotes right here and right here. And the first branch will look like this right here. And the second branch, or the branching out further, will look like this right here. and so on and so forth, where it's going to have asymptotes along these values right here. So we obviously can't evaluate each of these right here, but so I don't think I really want to. But so from the left side of like 1 pi halves, it's going to be positive infinity. From the right side of 1 pi halves, negative infinity. From the left side of 3 pi halves, negative infinity. From the right side 3 pi halves, it would be positive infinity. So just keep that in mind if you're being asked to, well, we'll say the limit as x approaches pi over 2 from the, we'll do from the left of f of x, that's going to be equal to positive infinity, and the limit as x approaches pi halves from the right of f of x is going to be equal to negative infinity. Obviously, there are infinite asymptotes, so there's infinite ways that we can evaluate them, but it will all be like the same. So, okay, and then looks like we got another one like that. I'm going to simplify this expression. So I know that cotangent of x was cosine of x over sine of x divided by cosine of x. I'm going to write that as cosine of x over 1. Do keep, change, flip. So cosine of x over sine of x times by 1 over cosine of x. And then that cancels, so that's going to be equal to 1 over sine of x, which is equal to cosecant of x. So it's going to be very similar to what we just graphed. If I graph something similar to that right there, it's going to be based off of sine of x, because we want to find where sine of x is equal to 0. And so sine of x, going to start by going like this right here, and so on and so forth, going down, coming back up, and then back down, so on and so forth. So these vertical asymptotes are going to occur, that's at pi, and this is going to be at 2 pi. So we have pi, we've got 2 pi. So the vertical asymptotes are going to be at x equals plus or minus, I'm going to say k pi, and k is an integer, any integer, even or odd. 1 pi, 2 pi, 3 pi, so on and so forth. The graph of cosecant is going to go like this right here, so on and so forth. So if we pick, say, pi, so the limit as x approaches pi from the left side of f of x, so from the left side it seems to be approaching positive infinity. And then the limit as x approaches pi from the right side of f of x, that looks like it's going to be negative infinity. So I think that should be good. Cool. I'll probably do a separate video for the rest of this.